Hello, everyone, and thanks for joining. This is Dave Eckroat from the IDEA office in the US. So today we're going to be presenting another webinar. This one is going to be on solving design issues, RFIs, and retrofit challenges faster than ever. I'm sure this is something that everybody's gets involved with at various times on different projects. So hopefully you'll find it informative. You can see here we have a little bit of a panel today. So we have Andrea Castello, who will be doing all the heavy lifting today for the presentation. Jan Gagon, who will be doing the Q&A at the end. And a new member of the US team, Andre Frederick. He's our marketing person. Recently moved here from the Czech Republic. So welcome to everybody, and just like to introduce the team here. So if we go to the next slide. Your typical slide, just a control panel for those of you that aren't familiar with GoToWebinar. If any of you have any questions, feel free to post them in the questions tab. Also, we do have a PDF of the handout available for download from the handout panel, so you can take care of that. So again, as we kind of look at the agenda for today, so we'll look at design, construction, and repair challenges. We picked a couple of specific things to look at. First one will be skewed connections. Then we'll go to on-site interferences, and then some retrofit of steel connections. So kind of show an example of each one of those, and then obviously we'll jump into the Q&A at the end. So next thing is just kind of some upcoming events. So some of you may remember we did a few roadshow events at the end of last year, traveling to different cities and doing a live presentation. We have one scheduled for March in Minneapolis. It's March 19th, so if you're in the Minneapolis area, definitely look forward to hearing more about that. We should be getting that information out next week. And we're also planning on doing these kind of throughout the year in various different cities. So if you'd like us to come to your city, definitely drop us a message and just let us know that that's something that you'd be interested in kind of seeing. Then we have our biggest event of the year, which is obviously the Steel Conference. This year it's going to be in Louisville, Kentucky. It's the first week of April. I believe it's April 2nd through the 4th. We will be at booth 106, so we're right on one of the main aisles. And definitely if you're going to be attending NASC, feel free to come by and just introduce yourself, say hi, ask some questions, maybe learn some things about our software. And then finally, just kind of, we have some placeholders for future webinars. So March 26th and then April 30th. The April webinar is very likely going to be on version 25, which will be released about a week before that. So just keep those in mind as you go forward. And with that, I believe I'm handing it off to Andrea, correct?
Yes, correct. Thank you, Dave.
All right. Thank you.
We'll turn off our cameras now. Start with the presentation, right? Okay, as David mentioned, the handout is available in the GoToWebinar panel. So if you want to look at the PDF while I'm speaking, feel free to download it. And I have some links there so you can explore them over there, right? So let's start with this presentation with the topic. IDEA StatiCa, as you know, is a software for steel connection design. But we wanted to showcase that the software is being utilized for different phases of the structural project, like during construction or reparation, and not only in the initial design phase, right? The following are some examples where we help some users to model and verify skew connections, for instance. So you can see here the examples for skew connections where the users maybe are asking for how to model bend plates, extend shear tabs, WT sections as connector for the skew beam. Also, we have some cases where we have where the user wants to model an skew moment connection. So you can see this example over here in the middle. And also, I had this interesting case where there is like two skew beams connected to a base plate using some bend plates here, as you can see, if I do a zoom over here. And then those bend plates are connected to a plate, and that is anchored to a concrete column. So these are the type of real cases that IDEA StatiCa is helping some of our users, right, during this design process, because the skew beams or the skew connections, you know it before, I mean, for during the design phase of the project. Now, these are some user cases that are related to a clash or interference issue during construction. In the first example that I am showing here, the user wanted to create a circular opening in the stiffener. I'll show you that in the software later today. The second is an on-site clash with another non-structural item that was found in the construction phase. I am also going to explain later this case using the software. And the third needed a notch to comply with high requirements. So in that case, the notch was near the connection. So IDEA StatiCa was able to analyze this connection and see if this notch was affecting the beam and if a reinforcement was needed for that portion of the beam, right? So those are some examples for that phase. Also, we have helped some users to retrofit connections, like adding a seat using plates to an existing connection so it can take more load, right? The other two cases are related to retrofit moment connections by adding reinforcement plates to the connections. So with these examples, you can see that IDEA StatiCa is being used in different cases that are not only for the design phase of the structural project. So today, I'm going to show you how IDEA can help you in these different cases. Not specifically for these examples, but I'll show you some tricks so you can extrapolate these operations to your projects. All right. Right. So let's start with the skew connections. These type of connections are known during the design process, as I mentioned, and the skew members are more common due to increase of complexity of the projects, right? Because of the geometry, clashes with other members, most of the members were required to consider a notch in the beam. These notches can decrease their strength and possibly develop a buckling issue in the web of the beam, right? So let's see how we can cover this. ASC manual gives some recommendations for this type of connections based on economy and constructability. They recommend bend plates when the beam has an skew angle more than 5 degrees. So this is kind of a summary, but if you check section 10 of the manual, you will see this whole section where they do some recommendations for these skew beams, right? So how IDEA StatiCa can help? Let's jump into the software to show you an example of an skew connection beam to girder using a bend plate, right? So I'll start this example from scratch so you can see what is the approach to model this bend plate connection, and then we'll come back to see the summary of what I show during the live demonstration, right? So for that, I am using IDEA StatiCa connection, right? And here you can see I'm in the initial page of IDEA StatiCa. For this, I'm going to use the geometry beam to another beam. And then here you can see that we have some templates to start with, but today I'm going to use this blank option, right? So I hit create project, and then the geometry will come. So the girder will be a 14 by 26, and we'll have another beam coming into the girder with an angle of 22 degrees, okay? So first, let's look at this top view. Now we have 90 degrees beam coming into this girder. So let's change first the cross-section of this member. You can see that this is a 12 by 79, so I can go to the plus icon and then pick another size for that girder. So that will be 14 by 26. So you can type here 14 by 26, find your section, and then say, okay, the same for this member. So that will be another type of beam. So another size. So I go to WAISC section and I type 10 by 12, right? Say okay here. And then you can see that this is 90 degrees. And one of the advantages of IDEA StatiCa is that there is no limitation in terms of the angles that you can input into this member. Like in this case, B1, you can start like 22, right, to put it in this side with 22 from the girder, or you can use minus 22, and then that will be in this side. So again, there is no limitation. You can use 45, 35, 32. So there is no limitation in terms of that angle. So I'm going to use minus 22 for this B1, right? And then you will see that because these two beams are different heights, they are connected through the center line, right? But then we can use this align option. So we align B1 top flange to the top of flange of the B member. So I can use to member plate here, and then I use B1 top flange, and then B top flange 1. So if I zoom in here, you can see that they are aligned to the top surface, and then you can pick here the surface that you want to align them, right? If that is different. Let me change the name of this member, and I'll call it girder, so I don't get confused whenever I am modeling another operation. Now let's start, let me go to this top view here, all right? And let's start notching the flanges of B1 member. To add connections or cuts to the plates, you can use a new operation, right? If you are kind of new to the software, we use these operations to add the connections. There are some standard connections. You can see like fin plate, plate angle, gusset plates, right? So those operations will help you to create like common connections, but this is not a common connection because we don't have a bend plate operation, let's say, but we can create this bend plate operation using other operations. So first, I'm going to set up a working plane to cut the flanges of this B1, all right? And that working plane will be related to the member girder, and then I'm going to rotate this 90 degrees here, all right? So that working plane, I'm going to use it as a reference to cut B1 flanges. So you can see the working plane there. And then I'm going to use a cutoff plate operation. Then this cutoff plate operation will be related to the top and bottom flange. Well, first, you can see that it's selected B, bottom flange 1, and then I can use a working plane here, right? So I'll select the negative portion, so you can see that now that is cut. Now I can copy this operation, and now I select B1 top flange, right? So we cut those flanges in reference to that working plane. And finally, I'm going to cut the web of this beam. So I can create a new operation here, and that will be B web 1, right? And I can decide, I can cut by girder web 1 here. And you can see that this operation is adding a weld, but we are not connecting that using a weld operation. So we'll call it no weld. We change that to no weld, so we delete that weld, and we'll use this offset to cut out this this plate. So you can use an offset of 2 inches, right? So you can decide, let me put the top view and transparent view here, right? So you can decide how off you want that web of the B1, right? So I'm going to use 1 inch here, right? So we don't have a long notch on the B1 web later when I am adding the notches there, right? Now to add the bend plate operation, I'm going to use an operation that we call a stiffening member. This stiffening member allows you to add a member, like a cross section, that will be part of your connection, and it is not a beam element, right? So in this case, the SM1 is under the operation list, as you can see here, and then I can click over the plus icon and I can use the database of IDEA StatiCa to create a stiffening member. So the trick here is to use this call form shape, and here we have this bend plate. So here you can specify the angle that you will use for that. So I am using 158, which is 180 minus 22 degrees, right? So we put the bend plate in the other side. So let me go to SM1, and this will have 8 inches, and the horizontal line will have 8 inches. I'm going to use a 3/8 thickness bend plate, and then I say okay. So you can see that this stiffening member is just placed in the center point of this model. So you can look at the wireframe view so you can see the node. So that is placed at the working point of the whole model. But we can set up this origin as a member, as another member. So we relate this bend plate to a member in the model. So in this case, I'm going to relate to the girder, to the web of the girder, and then I'll select the type of relation as a doubler, right? So one of the plates, which is this web 1, is going to be related to the girder web, right? I'm going to rotate this 90 degrees to have it vertical, right? And then what you can do here is you can use the mirror Y and Z to see if this is correctly located in the model, right? So mirror Y, we change it to this side, and then mirror C, so we are rotating that member. So now this bend plate is in the correct side. We just need to adjust the position in terms of this x-axis of the girder axis, right? Why? So we can move this member like along the girder, and then it's matching face to face this plate here, right? So the X position, I'm going to use -1/8, right? So this is face to face to the web, okay? So now we set up that. Now you can see that in this case, we can set up the length of the members here for the stiffening member. And this will be 5 inches, so that's how you will adjust the size. And then this will be 1 inch here, right? Now the next step is to add an opening on the web of B1. Why I'm adding an opening? You can see that here this web is clashing, right? So I can use a new operation, and that will be an opening operation. And then you can see that it's adding a circle opening on the girder. So let's change that to B1 web 1, right? And then we change it to notch option. This will be at the top because here we don't need it. So I'll put it on the rear side. In this case is this side, so you can see it here in the screen. And that opening will be 5.5 and then 1 inch high. And then we can change this to 1/2 inch, right? So we avoid that clash there. Now, if we look at the solid view, we can see that here we have a weld. So, I mean, you can keep this weld, so that will be welded to the girder, but if you need a bolt operation, you just turn off this and we add a bolt operation from the operations list. And then you pick the plates that you want to connect with that grid operation. And that will be, the first plate will be the stiffening member, web 1. So you can use the pick by cursor, and then the girder web 1 is selected here, so we can start setting up the bolts, right? So that will be, let me put the transparent view so you can see the dimensions from here. So that will be -1.5, right, from the starting point of this plate, and then I'll have 3 inches. So you can see that it's putting in the other side, so we can use negative values here. Now we use 1.5 from the top of the stiffening member, and then we use 3 inches here, right? So we set up that connection, and now let's add the weld operation from this plate to this B1, right? So we add a new operation, and now we can use a weld operation here, and then we are selecting this plate first, which is SM1 Web 2. We can use the drop-down menu, and then that will be connected to B1 Web 1, right? So you can see that here it's asking me for the edges to connect, and I can say 1, 2, 3. So graphically, you will see the welder, right? You can change the size of the weld here, and that's it, right? Now we can add a load effect here for B1. Let me turn off loads in equilibrium, and I'll add a shear force of, I added -20 kips here, right? So now we can run an analysis and see the results, right? So everything looks good here. But again, when you have this type of connections, usually you'll have a notch operation. So it's always beneficial, or it's always good to check the buckling analysis just in case, or to avoid any buckling development on the web of this V1, right? So in that presentation that I have, I show you some, I put some links on the PDF, so you can explore more about buckling analysis and how to assess if you will have an issue. But from what we're seeing here, everything looks good. And then we can look at the stresses. We can review bolts and welds, but in summary, everything it's fine. All right. So that's the approach how you can model bend plate in IDEA StatiCa. Let me go back to the presentation, right? So you saw that there is no limitation in the skew angle for beams or other members. You can use a line member tool to adjust the top of steel for the beams. We use a bend plate using a stiffening member. We use a cut operation together with working plane to notch the flanges, and we set up and obviously you can set up the working point to locate the force position of the shear force, right? And here you have a link to the buckling analysis article where you can read more about how this buckling analysis is assessed in IDEA StatiCa, right? I show you the bend plate, but obviously you can model other configurations. These are some examples from other users. You can see that you can model extended shear tabs, and they can be welded to the top flange, so it can work like a stiffener operation here. In this case, there was a WT section that was used as a connector. So again, we use a stiffening member to model that WT section. And also we can model this extended shear tab, but that shear tab is connected to an end plate, so that is also possible. You can use a notch operation to notch here this top flange, because probably you'll have a clash with the column if you have an skew beam to a column, right? So there are many options for this type of beams, but if you're new to the software, remember that we have this connection library where you can look for more options, and you can set up the geometry of the joint that you are looking for. You find a connection that you like, and then you can download that connection, and that can help you to have a starting point instead of starting from scratch, right? So, right. So let's continue with this slides. And now let's talk about on-site interferences, right? So this is a common issue during construction phase of a project. It's very common that unexpected elements clash with structural members, right? Like pipes, other non-structural elements, height adjustments, and so on. These examples can be found in one of the AISC sessions about field fixes and recommendations, right? And well, some of them are inevitable, and the engineer needs to verify if the structural element is okay with the proposed opening, or if a reinforcement is needed, right? So here you can see like this opening to the beam, or simply like openings to let the pipes go on, right? So also I have this example that I'm going to show you in the in the software. I have it here open. So this example was shared by one user where the original design had 8 bolts. But on site, they found that the base plate gusset connection was clashing with another non-structural concrete and steel element, as you can see here, right? This is an angle and this is like a wall portion. So the engineer needed to prove that the connection could work with only 5 volts or find a solution. So how IDEA StatiCa help? Well, in IDEA StatiCa, you can use the editor for the different plates that you model in the main connection. The user easily deleted, let me just play this. The user easily deleted the bolts and rerun the analysis to review the new stress distribution in the plate, right? And verify that the connection was okay with only 5 volts. So let's review the model and show you other operations that can help you to modify beams or columns with openings, okay? So let's look at the model that I am showing here that I have. Let me bring this to the screen. All right, so you can see here that this is like the original design. This HSS column with a bracing connection, and then here is a gusset plate. We use a base plate operation, right? And then we use a connecting plate operation. This connecting plate operation has like built in the gusset plate, the connecting plate, and this cap plate. So we have those options here, and you can set it up in just one operation, right? Then here we have a working plane and then a cut operation for the gusset plate, right? So if you look at the results, everything was okay with this connection. Okay, so if we look at the equivalent stresses and we look at the plates, and then you can scroll down and see here the CPL1A, which in this case was the gusset plate. It was everything under the limits. So we have 0.19% of plastic strain. So this was okay, right? Then if we go into the modified design, how the user or how you can modify this this type of models. So what I did to model this is that you can go to this plate here. You can click over this plate and you can see that this is CPL1, and here you have the editor. So in every operation where you have a plate, you have the editor. Like in this case, we have 3 plates. You can go through each of them, and then let's click over the gusset plate, right? So here in the editor is where you can add sub operations to this plate, right? So you can add offsets, roundings, a chamfer, or even a hole if something is clashing. So you can open that plate using a hole or even a notch, right? But then what I did here is that I added the extra holes where I deleted the bolts, right? Because the holes were there, were already constructed, let's say, on the plates. And then to edit the bolts position and just keep these 5 volts, I went to the editor of the tongue, which is that plate, right? So when you have bolts, you can go to the editor, and then you will have this table of bolts position. In this case, I already exploded this bolt grid table, right? And also you can modify the position of the bolts from here. And then you can pick one of them and delete it. So that's how you delete bolts from any operation. You come to the editor, explode it, and select the bolt and delete it, right? So that's how I deleted. Now we have these 5 bolts, and these holes here were created in the other operation, well, here as well, right? So I added the extra holes that were there, right? Those were important to see how the stress is affecting, how the stresses are around those holes. And then if we go to the check tab, we can see, I mean, when I rerun this analysis, we can see that's still okay, right? But then if we look at the stresses, you can see that, of course, the stresses change a little bit on that gusset plate. If we scroll down here, you can see that it increased a little bit, the elastic strain, but I mean, this is the advantage of IDEA StatiCa, that you can come, delete some bolts, and see if it's still working, right? So with this, we can ensure and we can prove, we can get a report and prove that this is still okay with those 5 bolts, right? And then you can see what is now the governing force or load combination. In this case, was the tension, and before it was a compression, right? So you can see how these changes happens, and you can have multiple models in one file, right? So that's how you use the editor and delete things or add openings into the plates. But now let's jump into a simple moment connection, right? And in the first slide, I show you that there was one user asking about adding some holes in the stiffeners. In this case, I show you that you can go to the editor and modify this stiffener, and then using a hole maybe, right? But this stiffener operation has 4 plates, right? So if I add a hole, that will be added in the 4 plates. So one approach here is to use our negative volume operation. So what is a negative volume? If you go to the operation here, operation list, you can see that here we have a negative volume. So in the negative volume operation, you can pick also a member, cross-section. You can pick a cross-section from our database, right? And you can model it. So this is how I modeled this like tube, right? And you can adjust the position of this negative volume that overlaps the plate that you want to cut out. So you model using negative volume. This doesn't exist in the model, right? It's only a reference. It's similar to the working plane. And then you can come and use the cutoff plate operation and cut that plate by negative volume number 1, right? So that's what I did. For instance, if I go to this operation, you can see the hole now here. Okay, so you could cut out portion of that plate or the members using a negative volume if it has like a specific shape, right? So you can see that I can add that, and then you rerun the analysis and see how the stresses were or the stress flow is affected on those plates. Also, if you remember on that slide, I was showing you like an opening, like a circular opening in the beam. So if you would like to model that, the approach is to use this negative volume and then use a cut operation, a cutoff member operation, and that will be cut by n volume 2, right? And then you can run the analysis and see how that is affected. So we can run this. Let's see if it doesn't take too long because this is a big cutout. So you can run the analysis, see how this is affected, and then come back and say, okay, I'll need a reinforcement, maybe adding a portion of an HSS here at the same size, right? And use that as the reinforcement. So this member has some stability. Yeah, so it will take more time, of course, because of the moment force that we have, right? It's not the same. So let me cancel this. So probably, oops, it finished at the same time. So yeah, of course, this member is failing, right? Then you come back and you can add some plates here and add a stiffener to it. There is also this opening operation, right? Let me just show you here. Let me just show you where is this. So this is the opening operation, okay? But this opening operation has this stiffener option. So let me show you how it looks without a stiffener. So the opening is just that opening, but then if you activate this stiffener, the software adds like this round section and it welded to to the beam, right? So this is useful to test those openings and then stiffeners with some clicks, and then rerun the analysis and see how it looks, how the stress flow looks, and then proof that is okay. All right, let me go back here to this presentation. I show you how to modify plates or bolts position using the editor, how to cut out sections using negative volume, and how to use opening operations. Okay, now let's continue to the last topic here that we have today. The last topic of the webinar is about retrofitting steel connections. As described in another AISE session that I am referring here, you have the link there. There are many reasons to evaluate an existing steel structure. It can be due to live or dead load changes, right? Because there is a building expansion, change in occupancy, new equipment in the building, framing the structure, right? For repairs, you can have failures due to fire or impact, corrosion, or seismic retrofit, right? So this can be the reasons that you need to retrofit a connection. So AISE shares some recommendations for simple cases that you can explore in that webinar with presentation, right? Some of the recommendations or solutions is to replace rivets with bolts, add weld reinforcements, add a welded or bolted stiff seat connection, or add a plate reinforcement, okay? So now let's see what we can do with IDEA StatiCa to extrapolate the AISE recommendations to other cases that you might find in your retrofit projects. So the first thing that I'm going to share is how you run this joint design resistance, which can help you to learn the maximum capacity of the connection. So if you want to retrofit a connection, you want to see what is the actual capacity of that connection, right? So you model the connection as it is, you run this joint design resistance, and then you can learn what is the maximum capacity. Then based on that, you can decide if you want to, how you want to reinforce, right? But first, to model like the original design, you can modify materials and bolt properties to match to the old material. You can also pick historic cross sections. Like in this case, this example that I am showing, it's using an S20 by 85. So IDEA StatiCa has some of the old cross sections, right? You can also add weld operations to reinforce the connection. As one of the examples of AISE is to add welds to a bolted connection. And then use the stiffening plates or members to test the planned reinforcement, like this seat angle over here, right? So first of all, in this example where they were evaluating an existing connection for an increased load, right? They were using an old material that's ASTM A9. So here you have the values FY and FU, and then you can come into IDEA StatiCa, go to the materials tab, and then copy one of the materials we have, and then you just modify the properties. And then you can save that old material into your database in case you want to reuse it. The same for the rivets. You can change the bolt's properties. So here you have the values, and then you can modify one of the bolts assemblies that we have, and then you change these properties from here. And finally, as I show you here, the beam that was used, it's an S20 by 85, so you can pick from the IDEA StatiCa database. So that is what I did. Let me just bring this model here where I showcase that. Let me show you the original design. Okay, so if you go to the materials tab here, right, you have the materials, cross sections, and bolt assemblies that you have used in this file, right? So you can see the properties of them from here. And then in this case, I already have this ASTM A9 material, okay? But then if you want to create a new one, you can copy this the current one, the A992, you copy that, you edit it, and you save it to your database. You can see that it's MPRL, that's the IDEA StatiCa database, right? And that can be available for other models. And the same for both assemblies. So you can copy, edit it, and then save it. And you save it with your own name. So that's what I did for these bolts here. Now, this is how the connection was, like the original design in that example, right? So you can run this joint design resistance analysis. You can come here to the name of the connection, you click there, and then that's where you change that. You run the analysis, but before you put like an initial load, I just put minus 50 kips, right? And then when you go to the check tab, you will go to this tab and see this percentage. So that is the maximum percentage of the applied load that this connection can handle. So we have an extra 53%. So you will multiply that force by 1.5, let's say, in this case, and that will be your maximum capacity of the connection, right? So that's how you learn what is the maximum capacity in terms of the applied loads. And then later for connection 2, for the fix, what I did is here you have this, we call it clip, but it's a clip angle, right? You can set up here. And then I use a stiffening plate operation to reinforce this connection. So again, I am using a doubler as a type of relation to the other member. Then I use another plate, and that was a rib operation from other member, and some cut operations. But you can see that there weren't like many operations extra, but everything, I mean, every possible reinforcement is possible with IDEA StatiCa by using these stiffening plates that you can place it wherever you need it here in the model. And then once you have that, you rerun the analysis and test if that is okay for the reinforcement, right? So, this is how IDEA StatiCa can help you to retrofit these connections. I have more information in other blog posts that we did at the end of last year. Yeah, so let's jump into the Q&A session.
All right, thanks a lot, Andrea.
Yep.
So feel free to ask more questions. Actually, on the right-hand side, you'll have the questions panel. We have a few questions so far, but I think we'll have a bit more time with 4 more questions. And as a reminder, you can download the handouts on the right-hand side as well if you want to click on these links that you see on the screen. So you can find them there. First question, why did you use a cold form connection for the bent plate for that very first example? So would you mind actually just showing the cross-section navigator and explain the few different tabs?
Yeah, so basically it's not that it's a cold form, but let me just click over the plus icon, and that's where we have this, let's say, shape, right? But let me go back here and edit it. So you can use that shape, but then you can use the material that you need here. It is not that it's a cold form shape, it's just where we are saving this shape, if that makes sense.
It's just a naming that we used for these, but it's going to be checked per AIC, just like a regular angle would be if you were to choose an angled section. What about a custom shaped plate? Can you show how to easier edit using the plate editor, but also maybe show the DXF import?
Yeah.
Where to find that?
Yeah. So yeah, let's say we want to add a plate, random plate here. So we can just come here to the stiffening plate operation, and we are always recommending this to use the relation to another element, to another plate, right? So I'm using the doubler here, and then you can shift this like 6 inches. that can help you to shift this plate. So in this case, we just have rectangular shape from here. You can go to the editor and then add sub operations like a bevel here or a notch, 5, 2, right? And then you just apply that and then say okay. So you have that notch over there. But if you want to bring, also we have circular shape, but if you want to bring like a specific shape of the plate, you can always use polygon. When you pick polygon, then you need to pick an DXF shape, right? So you click over DXF, so you'll need to draw that in a CAD file and then save it in DXF format. And then you can pick it from it. I don't have a DXF to show more than that, but yeah, that's how you'll do it.
Several questions actually about the PDH certificate. So just to reiterate, these will be sent directly from GoToWebinar probably next week. So you'll receive a CEU certificate that you can send to your state. There were a few questions about links, even though it's not directly related to this webinar, integration with third-party software. I do want to mention that if you were to use SDS2 or Tekla, any detailing software, and you were to detail these connections in or directly into IDEA StatiCa, so the bend plate, for example, can be brought over automatically if it's easier for a detailer to create that connection in a detailing software instead of doing it in IDEA StatiCa. There you go. You're showing this. So can you just show how you found that link? So it's through the website.
Yeah, so you go to ideastatiCa.com and then you can come here to the BIM tab and supported integrations.
Exactly. So here you'll find tutorials for all the different links, both BIM software, global analysis and detailing software can be linked with IDEA StatiCa. IDEA StatiCa reported local deformation in one of the connections. Is this only applicable to HSS connections?
Yes. Yeah, that'll be only for HSS.
Mm-hmm.
Yeah.
It's just going to be an additional check for HSS members.
Yeah.
And in that scenario, do you know when does the local strain deformation controls compared to the typical plate strain deformation, or is it unrelated? Is there a link between the two?
The local deformation will be 3%, but that will be under deformation, and then you have the material property, which is going to be the stresses and strain, right? So probably if you're over 3% of that local deformation, you'll have a strain happening on the plate of that HSS. But if you have further questions, like for a specific one, you can write here and I can follow up on that one. Or if you're a user, remember that you have technical support through the user portal and you can submit a user case, right?
Can you show how to use oversized or slotted holes in both connections?
Yeah, so for the bolts, we can always go to the editor and use this this option, right? But that will be just slotted holes. And then you apply that.
And the last question I see so far is, does IDEA StatiCa have any of the AISC historic shape database? Or should you just create it yourself from scratch?
Yeah, if you come here, you will see that we have some kind of old, like the S sections, HP, M, and S. So those are like preloaded databases, right? So you'll see that they are AISC. If there is a shape that we don't have, you can always come to the, let me click again here, to this I section like editor, and then you can input the actual dimensions of those shapes.
Will you have these models on the website, the few models that you went through today?
Yeah. I can upload it. On the webinar website, we'll have the PDF again, the presentation, and I can upload the models. Some of the models I have here. Right?
Yes, perfect. For slip critical bolted connections, can the software can also analyze the coefficient of friction required?
That's something you will input. Yes. Yep. You put it here. So you put it here, and then to change it to slip critical, you come here to the grid operation or wherever the bolts were set up, and then you change it to friction.
Just to show the flexibility of the software, someone was asking, can you show non-regular bolt pattern, like 3 bolts in the first row and then 2 bolts in the second row? Can you just show how you would make that modification for this one?
Yeah, so, well, you can come here and use the staggered options, right? Like that, right? You can always use the options that we have here. And then if you want to have 3 at the top, 3 and 2 at the bottom, then what we can do is adding, let me add another 3 inches there. That was down here. 3 inches. Negative value here. Right. And then what you will do is going to the editor and explode it and delete it from here. So you delete it and then apply, and you can see that you delete it from the main model. And then you can also, when you explode this table, then you can modify the values from here. All right.
What is special about IDEA StatiCa compared to RESA connection or RAM connection? What can only be done in IDEA StatiCa? It's a loaded question. I think we should be careful. But,
go ahead, Jan. It's your turn.
It's mostly about the flexibility. RESA and RAM connection are great tools, but they're just going to follow the AIC design guide examples. As soon as you step out of these examples, you're going to have to either use your brain, meaning you do it by hand, or you can use a finite element analysis approach, which is what IDEA StatiCa offers. So it's mostly about the flexibility, which doesn't necessarily mean complexity. As mentioned, it can just be a basic bend plate or a skew angle, or simply having some horizontal load in a beam-to-beam configuration, which would force you to be to check it by hand if you were to use other software. IDEA StatiCa is going to be able to go over these models and give you accurate results because of the methodology that we use, while also satisfying AIC requirements. And we have a lot of verifications available on the website if you're interested to view how IDEA StatiCa compares to AIC and the verification that we've done, or that different US universities have done in the US to compare IDEA StatiCa to the AIC methodology.
All right, you did it great.
And will there be an IDEA StatiCa user day this year? We don't really have that in the US, but I guess we are doing now the roadshows, meaning we create our own little conferences in different cities in the US. Last year, I believe we did Atlanta, Kansas City, Philadelphia, and Denver. And so the next one will be in Minneapolis in just a few weeks. So I'll be the one handling that roadshow, and we'll have more actually coming up in May and June, I believe. So we're trying to meet our users in person more. And if you want us to come to your city, just let us know. We do travel a lot, so we'll be happy to come by and either organize an in-person office or in-office presentation or organize a roadshow for you to also meet other local users of the software. Just send us an email and we'll put that on our calendar. And it is 1 p.m. Eastern, so I do not want to take too much of your time. If you ask more questions in the chat, we'll be able to answer them by email afterwards. No worries.
Right. Thank you. And well, see you soon.
Thanks, Andrea. Thanks, everyone.